Climate systems. In this lesson, we'll look at the science and engineering practices of asking questions and defining problems, developing and using models, analyzing and interpreting data, constructing explanations, and designing solutions. Our cross-cutting concepts will include patterns, cause and effect, scale, proportion, and quantity, systems and system models, energy and matter, as well as stability and change. What is heat transfer? The sun is the ultimate external source of energy for our planet. Energy reaching Earth drives global interaction between the atmosphere and the surface, creating wind and influencing ocean currents. Heat is transferred by three main processes. The first is conduction, the second is convection, and finally radiation. Heat energy only flows when there is a temperature difference between a warmer area and a colder area. Differential heating. Radiation, or solar energy, from the sun does not hit Earth everywhere at the same time and in equal amounts. This means that some places receive more heat while others receive less heat. This is known as differential heating. Factors that affect the amount of energy reaching an area include altitude, or the height of the land, and latitude. That's how far north or south of the equator a place is. So why is the South warmer than the North when we are talking about the United States? The southern U.S. has a warmer climate than the North. This is because the sun heats the Earth's surface unevenly. The Earth is tilted on its axis in relation to the sun. Because of this tilt, areas closer to the equator get more concentrated sunlight than areas farther from the equator. Latitudes near the equator, like the southern U.S., receive more of the sun's energy than places further from the equator, like the northern U.S. This is because the solar radiation is more direct and concentrated over a shorter area. As we make our way northward, that energy is spread out over a much larger area of Earth's surface. Insolation. This diagram illustrates the impact of latitude on the amount of solar energy received. Solar energy at higher latitudes is spread out over a larger area, which means that it is less concentrated. Lower latitudes are closer to the equator. Recall that the equator is the imaginary line that goes around the middle of our planet. Solar energy at a lower latitude is more concentrated. The amount of solar energy received in different parts of the world is known as insolation. So when you hear the term solar insolation, we are talking about the amount of solar energy that is received in that area of the planet. So what is climate? The amount of solar energy received is one of the factors that influences an area's climate. Climate is the average rainfall and temperature conditions in an area. Oftentimes, that is over a large period of time. The Earth is divided into climate zones, which help scientists to characterize areas. They include arid climates, which are hot and dry, tropical climates, which are warm climates with a distinct rainy season, polar climates, these are cold, dry climates. What climate zones can be found in the U.S.? Examine the image to find answers to this question. Ocean circulation. Solar radiation heating the Earth's surface also drives convection within the oceans, producing ocean currents. There are two circulation systems in the ocean. Surface currents involve the top 10% of water in the ocean, and deep currents. These occur below 400 meters of depth. Ocean currents are called gyres. They spin clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Ocean water and density. The density of ocean water varies due to differences in temperature and salinity. Salinity is a measure of the saltiness of water. In this image, dark blue areas show regions of higher density. Recall that liquids or gases that have a higher temperature tend to be less dense than those materials with a lower temperature. So if we're looking at the Arctic or the Antarctic regions on our planet, temperatures are much lower and therefore density is much higher. The density of the surface water of the world's oceans is calculated from measurements of temperature and salinity. In this image, the light blue regions are of low density, with the darker blue being regions of high density. The results show that while the variation is relatively small, there are 3 stable regions of denser water, one in the north around Iceland, and the other 2 in the south, associated with Antarctic ice shelves. These masses of water sink, driving the thermohaline circulation and the world's deep ocean currents. This has a major effect on the world's climate. The data used in this map is from the World Ocean Atlas. Ocean salinity. Ocean water at the poles is colder due to the effect of insulation on the Earth's surface temperatures. However, polar ocean water is also saltier. When water freezes, it forms ice crystals that have little room for salt molecules. The salt is left in the liquid seawater, resulting in areas with higher salinity. Salty water is denser than less salty water. This dense water sinks, and warmer water from near the equator moves in to fill that empty space. The resulting deep current moves around our planet in the world's oceans. Oftentimes we call this the global ocean conveyor belt. Thermohaline circulation. This image shows the major warm and cold currents of the global ocean conveyor belt. This process can be called the thermohaline circulation. As polar sea ice forms, the salt is left behind, increasing the concentration of salt in the ocean. The salty cold water is more dense than warm fresh water, and it sinks to the ocean floor, pushing water through the world's ocean like a plunger. The global conveyor belt is thought to play a fundamental part in regulating the Earth's climate. It does so by transferring heat and moisture around our planet. Some scientists predict that this global circulation, if it was to stop, temperatures in certain regions, including Europe, could decrease rapidly. It is thought to have stopped or changed direction in the past, causing significant changes in global temperature. Ocean currents. Ocean currents have a big effect on climate. Warm currents keep coastal areas and islands temperate, whereas cold currents do the opposite. The California current is such an example of a cold current. It is a major oceanic current that brings water from the north along the Alaskan coast south towards the west coast of California. Temperatures on the west coast of the United States are oftentimes several degrees cooler than the east coast during the same months. So what effect do you think this has on California's climate? And what would happen if the California current were to change course? What processes can affect the climate? So far, we have learned about the processes that have created habitable climates on Earth. However, climates are constantly changing, and there are a number of factors that can affect them, including El Niño Southern Oscillation, volcanic eruptions, human activity, solar output, and changes to Earth's orbit and axis. So what do we already know about these processes? The El Niño Southern Oscillation. El Niño Southern Oscillation refers to the fluctuation in ocean temperatures in the equatorial Pacific Ocean. It has two distinct patterns. The first is El Niño, which leads to warmer than average Pacific sea temperatures during the winter months. The second is La Niña, which leads to colder than average Pacific sea temperatures. So how does El Niño Southern Oscillation affect the climate? El Niño and La Niña climate variations occur about every 2 to 7 years, but El Niño is more likely to happen. Climate changes linked to El Niño include dry conditions in the Philippines, Australia, and Indonesia, heavy rainfall in Peru, Brazil, and Ecuador, and tropical storms or hurricanes in Japan, Korea, and the US. So when do you think the last El Niño event was? How do volcanoes affect climate? Volcanic eruptions eject thousands of tons of dust, ash, and gas into the atmosphere. This leads to an increase in the amount of solar energy reflected from the Earth. This is called the albedo. This results in a cooling effect. Mount Pinatubo was a volcano that erupted in 1991 in the Philippines. It ejected a very large cloud of sulfur dioxide and other gases, along with large amounts of dust. The eruption caused a 10% reduction in the amount of sunlight that reached the Earth's surface in 1991. What is the greenhouse effect? The greenhouse effect has a major impact on the temperature of Earth. In stage 1, radiation from the sun in the form of light waves enters the atmosphere and warms the Earth. In stage 2, infrared radiation is produced by the Earth. Some of this heat travels through the atmosphere and escapes into outer space. In stage 3, greenhouse gases in the atmosphere absorb some of the heat. It is then reflected back to Earth. This causes the temperature of the Earth to rise. In stage 4, increased levels of greenhouse gases in the atmosphere trap more of the emitted heat. This leads to an increase or a greater increase in the Earth's temperature. What are the greenhouse gases? The Earth's atmosphere is made up of different types of gases. Infrared radiation produced by the Earth is absorbed by greenhouse gases. We're going to look at a number of the different gases and whether they are greenhouse gases or not. Carbon dioxide traps infrared radiation, and this warms the atmosphere. This gas is a greenhouse gas. Methane. Methane traps infrared radiation, and this warms the atmosphere. This is also a greenhouse gas. Nitrogen makes up about 78% of the atmosphere, but it does not trap infrared radiation. It is not considered a greenhouse gas. Oxygen makes up about 21% of the atmosphere, but it does not trap infrared radiation. Again, this is not a greenhouse gas. Water vapor. Water vapor traps infrared radiation, and this warms the atmosphere. Therefore, water vapor is considered a greenhouse gas. So what are the order of events in the greenhouse effect? Number 1, the Earth is warmed by light waves from the sun. Number 2, the Earth produces infrared radiation. Number 3, some infrared radiation escapes into outer space and some is trapped by greenhouse gases. Number 4, the Earth maintains a temperature suited to life. Number 5, greenhouse gases in the atmosphere increase. And number 6, more infrared radiation is trapped and the Earth's temperature increases. Human activity in the greenhouse effect. The greenhouse effect is important in allowing the Earth to sustain life as we know it. Without it, the Earth would lose heat energy too quickly and would become too cold. However, many human activities release large amounts of greenhouse gases into the atmosphere. These gases contribute to the process known as the enhanced greenhouse effect. The enhanced greenhouse effect means that more solar radiation is trapped by the Earth's atmosphere, gradually making the planet warmer. What future problems might this lead to? What activities increase greenhouse gases on our planet? Human activities that increase greenhouse gases include large-scale agriculture and meat-based food production, which involves releasing large amounts of carbon dioxide and methane into the atmosphere. The burning of fossil fuels, such as coal, oil, and gas, which releases CO2 and sulfur dioxide into the atmosphere. Deforestation, this is the removal of trees from an area. Trees absorb CO2 as part of the process of photosynthesis. Cutting down trees reduces the amount of CO2 absorbed. Solar output. Solar output refers to variations in the amount of energy received from the sun due to more or less solar activity. Scientists monitor dark patches on the sun's surface called sunspots. When there is more frequent sunspots, this can indicate increased intense solar activity. Some scientists theorize that more sunspots could lead to changes in global climate. However, it's important to point out that sunspot activity has decreased slightly in recent years. Orbital change. The Earth's orbit around the sun is elliptical, meaning that it is an oval rather than a circle. I must also point out that the ellipse of Earth is nearly that of an oval, or nearly close to a circle. Over time, this orbit adjusts slightly. This means that the distance between the Earth and the sun varies. When the Earth is closer to the sun, it receives more solar energy. This process of orbital change happens very slowly over approximately 100,000 years. Earth's axial tilt. Every 41 years, the Earth repeats a cycle of tilting back and forth on its axis. This is a very small change. Its angle tilts between about 24.5 degrees and 21.1 degrees. However, it is likely to affect insolation levels on different parts of the planet. A more closely toward zero tilt would mean that we did not have seasons. A more pronounced tilt would cause seasonal changes to be more drastic. A location of 43 degrees north of the equator might be tilted towards the sun, receiving more solar radiation than usual with a greater tilt during one specific season. Whereas at the opposite season, we would end up with a more pronounced tilt away from the sun. The history of the atmosphere. How has the Earth's atmosphere changed over time? Scientists currently think the Earth is around 4.5 billion years old, or 4,500 million years. So starting at the beginning, around 4.5 billion years ago, when the Earth was formed, hydrogen and helium were the main gases in the atmosphere. These gases are very light and could have floated off into space just like helium balloons. Around 3.5 million years ago, volcanoes released carbon dioxide, water vapor, and small amounts of methane and ammonia from the Earth's core to form the atmosphere. This early air was similar to the present-day atmospheres of Mars and Venus. 3.5 to 3 billion years ago, water vapor held in the atmosphere cooled and condensed to form oceans. Some of the CO2 dissolved in the oceans. Liquid water is essential for life. Fossil evidence suggests to scientists that life on Earth started in the oceans. 3 billion to 500 million years ago, the gradual evolution of photosynthesis in plants and algae increased the amount of oxygen in the atmosphere. The oxygen, or O2, from this process formed the ozone layer, which is O3, which filtered out harmful UV rays from the sun. 200 million years ago, the increased amounts of oxygen, O2, reacted with ammonia, NH3, to form nitrogen, N2, and water, H2O. The composition of the Earth's atmosphere has remained almost the same for 200 million years. Today, human actions are changing the balance of gases in the atmosphere. Burning fossil fuels releases carbon dioxide and other pollutants. How might this affect the environment and atmosphere now and in the future? How have surface temperatures changed? This graph shows the average global land and ocean surface temperature change between 1880 and 2018. What general trends do we notice? Think about some of the short-term influences on global climate that you have learned about in this discussion. Can you relate any of them in the data shown? How has the volume of polar ice changed? This graph shows the change in the volume of Arctic sea ice between 1980 and 2017. What general trends do you notice here? When glacial and sea ice melts, it leads to rising sea levels. What problems might this cause for future generations? Problems associated with melting ice and sea level rise include increased ocean salinity and acidity, increased erosion and slumping in coastal areas, saltwater encroachment into freshwater reservoirs as well. Please take time to explore these true and false statements